Today's topic that we are going to see is characteristics of PN junction diode. Myself, Dr. Ranjith Inbaseelan, Assistant Professor, PG and Research Department of Physics, Bishop Weber College. Here we have two circuits, that is forward bias and reverse bias. Forward bias, which means the positive of the diode is connected with the positive terminal of the power supply, and the negative is connected to the negative terminal of the power supply. Likewise, reverse bias, which means positive of the diode is connected to the negative of the power supply, and negative of the diode is connected to the positive terminal of the power supply. These are the two different connections. In this experiment, we are going to find the PN junction diode's resistance value, the resistance value. Here, as you see, the positive terminal of the power supply is connected through a milliampere, and it is connected to the PN junction diode. This is the symbolic representation of PN junction diode. Here, this positive is connected directly to the positive terminal of the diode. Likewise, the negative comes to the negative terminal. Negative comes to the negative terminal of the negative comes to the negative terminal of the power supply. Here, when we are measuring the current, that is ampere, milliammeter, that is connected to this circuit. This is connected in series, and when we want to measure the voltage, it is connected in parallel with the power supply. Power supply is connected parallel to the voltmeter. Here voltmeter is connected. We cannot connect the voltmeter like this in series. It will not give the correct information, correct voltage. Likewise, this ammeter cannot be connected in parallel. For measuring the current, we should connect in series. For measuring the voltage, we should connect in parallel with the power supply. Imagine if we have a graph like this. This is the graph sheet, and the graph sheet is divided into 4 sides. Here we will get a graph. Here this is the volt. Here it is divided into 4, and this is x axis, and this is y axis. Here we will have voltage, and here we will have the current value, that is milliampere. So milli, which means into 10 to the power minus 3, and voltage, that is V. Here forward bias, we will get a forward bias graph like this. We will get a graph like this. Imagine this is 1, this is 2, 3, 4 and 5. Likewise, this is 2, this is 4, this is 6, and likewise this is for the example. If we get a point here and another one here, and the next point and the next one, if we want to plot a slope for this graph, take a slope like this. and for the slope this is x, this is y, and this point will be z. Okay, and from this we can calculate the resistance for the PN junction diode. And imagine this is the graph we will get for reverse bias. This is reverse bias and this one is forward and this one is forward bias. Likewise, for reverse bias we will get here, this is a voltage value 1, 2, 3, 4, 5, 6, 7 and this 8, and we'll get here, imagine this is 4, this is 8, this is 12 and this is 16. If imagine we are getting values at these points with respect to 4, 5 and 6 likewise. Okay, here also we can plot the slope value like this. This is the slope value. Here we have taken x, y and z. Likewise, you can take it here as this one is A, this point is B and this point is C. In this Ohm's law, that is equal to V equal to I R. V is voltage, I is current, R is resistance. From this we are going to find the R value. So we will get V by I. If it is forward bias, we should substitute into 10 to the power minus 3 because this is milliampere. For milli, 10 to the power minus 3. Here for reverse bias, it is microampere. So into 10 to the power minus 6. If it is reverse bias in this formula, if we need to find the reverse bias, we should substitute 10 to the power minus 3. Here is the model calculation. V equal to IR, so R, I into 10 to the power minus 3, here R equal to, if it is B minus C, we can draw here. Only the diagram part I will draw here. That is, if it is, imagine this is the slope, this is V, this is A and this is B and this one is C. So for voltage, this is voltage, so we need this distance from here to here. This distance is voltage. So if we subtract B minus C, we will get the voltage value. Here it is 0.97 minus 0.6. And likewise A minus B, which means here that is the current value, milliampere value is here, that is unit of current is milliamp. So from here, this point to this point, this is current I value. So I have written A minus B for milli into 10 to the power minus 3, 30 minus 3 into 10 to the power minus 3. For calculation purpose, if we move this into 10 to the power minus 3 to the top, we will get 10 to the power plus 3. For this, into 10 to the power minus 3, and if we after multiplying, we will get around resistance value for forward bias of PN junction diode, PN junction diode, we will get around 33.70 ohms. This is for forward bias, and this is for reverse bias. I will draw the graph here. It will be like this. See here, and if we take a slope from here and this point, imagine this is I, current, unit microampere. So for micro, if it is micro, I have written 10 to the power minus 6, 10 to the power minus 6, this is R equal to V by I into 10 to the power minus 6. This is in denominator. So for finding V, imagine this is X, Y and Z value. For V, this is V, this is volt, this is voltage. So we need the distance from here to here. We need this is voltage. This is voltage. So from here to here, we need to subtract bigger number minus smaller number, Z minus Y. We can write Z minus Y. We will get voltage. Likewise, if we need I, current value, we need to look into the Y axis from here to here, the distance from this point to this point. Here the bigger number will be Y minus X. So we need to Y minus X within brackets into 10 to the power minus 6. Okay. Likewise, here written, for example, if Z is 25, 10 and Y is 20, X is 0.25 into 10 to the power minus 6, and if we move this 10 to the power minus 6 to the numerator, we will get 10 to the power plus 6. This will become plus, and after subtraction 15 10 to the power 6, and denominator is 19.80, and so amount for the numerator and denominator. A huge value we will get for the resistance value of reverse bias. R is resistance of reverse bias value for the PN junction diode. Okay, thank you.